Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprints. Today we are going to talk about capacitor and their technical parameters and what is the usage of it and how it is going to be comparative when we are finding an alternative solution. And we are talking about what are the different types of capacitors and what is the usage of that, and when we are going to select this any given parameters, we have to find which is better and which is not better. So we have to go in detail to reasoning for to choosing the right value when it comes for respective parameters. So with that said, let's get into to understand what is the capacitor. Capacitor is a passive component that stores the electrical energy in the form of in an electrical field, right? So it's made up of two conductive plates and by an insulating material called dielectric. So what is the capacitor does? Basically, it stores the energy and filter the noise, smooth the DC power, and couple the AC signal, and stabilize the voltage, set the timing constant when it comes for RS circuits. So majorly the key parameters, if you ask me, capacitance is always the first, which should be an exactly match irrespective of any given application, right? So if there is a 9 picofarad, should select the 9 picofarad as an alternate solution as an example. So voltage rating should be which should be an higher side of it when it comes for selecting any kind of capacitance. So ESR is an internal resistance and leakage current is small, reduce the unwanted current flow through in dielectric. So let's talk about what is the different types of capacitor as we discussed in the previous video about the resistor. Same here also I want to categorize into three buckets. One is by construction, other one is by material, and the last one is by application. So majorly there are 4 to 5 categories we have as a capacitor. So it's a foil capacitor and film capacitor, ceramic capacitor, electrolytic capacitor, and tantalum capacitor. So when it comes for foil capacitor, is made up of metal foil and dielectric film. So which nothing but a polyester, polyethylene, and PTFE. So metal film capacitors are thin metal coating on dielectric, small, self-heating, stable, right? So, and when it comes for ceramic capacitor is called MLCC, which is multi-layer ceramic plates plus a dielectric metal, small in size and high frequency. And electrolytic capacitor are widely used electrolyte. And tantalum capacitor is made up of tantalum pellets plus a dioxide layer, stable, compact, and polarized. So by material, if you ask me, there are classic example like I would categorize two things. One is classic one, which is made up of dielectric composition of COZ and NPO. And class 2 ceramic capacitor are made up of X7R and Y5V and Z5U. So we majorly used X7R in class 2 example. So polyester capacitor are low cost in general filterings application they are going to be used. So polythin are high stability and low ESR, high frequency and precision application this kind of used in. So polycarbonate is long term stability and PTFE is Teflon, low loss, RF precision circuitry is going to be used. By application, if you ask me, power filtering circuitry where DC power smoothing and SMPS, electrolytic and film capacitor are widely used in this kind of materials basically. So decoupling and bypass capacitors application where remove the noise near the ICs basically. So ceramic and MLCCs are used for decoupling and bypass capacitance application. So timing circuitry, when it comes for no NPO and polyurethane stable dielectric RC circuits, these timing capacitors are used widely. So high voltage capacitance, in this application, we are using polythene oil based inverter and pulse circuitry applications. We are using these high voltage capacitors. RF and microwave capacitor applications, we are using COG and NPO supercapacitors, which low losses and high stable in supercapacitors. So this is a major applications where we are using this kind of capacitor. So I would like to correlate in layman language what is mean by capacitor, and when we correlate all these technical parameters, how we can easily understand, right? Let's say assume as a capacitor is nothing but water, contents of water in a bucket, right? So you should when it comes for capacitance, you should match, means we should able to handle the quantity of water which fulfill the bucket. So it should not be exceed or should not be less, so it should be always same as when it comes for capacitance value. So when it comes for voltage rating, how much pressure the bucket can survive. So what I mean, so always higher the voltage is better when we are going for finding an alternative solution. So next come for ESR, flow friction when water leaves the bucket, right? So should match always. Lower ESR is better. Higher ECR causes heating and ripple, right? So dielectric material, always use the same dielectric material because it's derived to different parameters. If I'm wrongly choosing the different material instead of X7R, I use COG, then it's causing an issue, entire circuitry. So packaging, again, the packaging should match, it should not be deviate, or else it's causing for change in entire circuitry board. So temperature rating, heat resistance on the bucket, right? So when the temperature is higher side of it, then the capacitor should be withstand. So that is majorly when we put into the layman language. So let's understand in the technical parameter, technical wise, why we have to choose the higher value or lower value when it comes for selecting the alternative solution. So as we discussed, voltage rating should be an higher side, means when there is a pressure limit is high, then irrespective of the it's always voltage should be at a higher level because the depends on pressure limit, right? So when the capacitor exceed the parameter, then higher the voltage rating can be withstand to filter out or reduction in the noise, right? So again, like one is important parameter when it comes for leakage, it should be lesser is better because there is a high chance of frictions, or in layman language, if you ask me, dipping in a bucket, the water dipping out of the bucket. So low leakage current is always better when we are selecting a alternative solution. So with that said, I hope this video helped a lot to understand what is a capacitor and types of capacitor and made up of what are the different materials, which application we use, which kind of material, right? So with that said, I hope this tutorial would help a lot to the users who are watching this, and I would like to see your feedback so that I can make such a nice video which could help you to understand all the technical parameters of any given component. With that said, thank you so much and have a great